In this question, we're given that a single force acts on a body and moves it along an x-axis. The figure here shows the velocity versus time for this body. For each interval in this graph, we want to give the sign plus or minus for the work done by this force, or state that the work is 0. Now, in order to relate the work done to a graph of speed versus time, we can immediately recall the formula for the work energy theorem, which tells us that the work is equal to the change in kinetic energy, and so the work done will be equal to half mv squared, mv final squared, minus half mv initial squared. So we can then deduce that if v final is larger than v initial, we can directly know the sign of the work done. Now, if we look at the intervals that we have here from A to B, we can see that the speed at B is larger than the speed at A, and so the work done is going to be positive. For the second interval, which is BC, we can see that the speed is the same, so this means that the change in kinetic energy will be equal to 0, and so the work done is going to be equal to 0 as well. For the interval CD, we can see that the speed at D is 0, so the speed at D is less than the speed at C, and this means that the work done is going to be negative. And finally, for the last interval DE, we can see that the speed at D is 0 while the speed at E is negative. However, we can still see that if we look at the squares, the speed at E squared is larger than the speed at D squared, and so delta K will be positive because the speed at E is the final speed, and so the work done is going to be positive because it depends on half mv squared minus half mv initial squared. So the work done here is going to be positive even if the final speed is negative.